So question 15, boys and girls, we have a uniform wooden rod of length 100 cm and mass 50 grams. So I visualize the problem. I have a rod of length 100 cm means 1 meter. I change to SI unit. The mass is 50 grams. So 50 grams is 0.05 kg. Okay. Then is freely pivot at its center, so is pivot at the center. When it pivot at the center means that this one will be our axis of rotation. This one will be our axis of rotation. The pivot point is always our axis of rotation. So an arrow of mass 100 gram moving at the speed of 60 meter per second strike and stick to one free end of the rod. Okay. So we have an arrow, this arrow is moving with the speed, okay, this is my arrow. So this arrow is moving with the speed of 16 meter per second and it strike and stick on one end, okay, one free end. Oh, so the arrow will strike on this free end and then it stick on the rod, okay. Then what happened? The rod will rotate in a horizontal circle. Okay, so I redraw. So let's say this is our final situation. So we have the same rod, pivot at the center, and then the arrow is sticking here, stick at one of the free end. Then what happened? What happened to the system? The system will start to rotate in horizontal circle. So it will start to rotate Okay, dia akan mula pusing pusing macam ni. Okay, it will start to rotate in a horizontal circle. So this will be our initial situation, and this one will be our final situations After the arrow stick on the free end, then the rod start to rotate. Okay, then we are given the moment of inertia rods about its center is 1/12 ml squared. So this is the moment of inertia for the rod. Formula to calculate the moment of inertia for the rod. Okay, so if you remember if you refer back to your lecture notes for different various uniform rigid body, we are going to have different formula to calculate the value of moment inertia. So, for example, in this question, we have a thin rod. We have a rod pivot at the center. So, our moment of inertia will be 1/12 ml squared. Okay? Then maybe you are wondering, then teacher, how I'm going to calculate the moment of inertia for the arrow? Okay, so what about the arrow? So the arrow we will treat as particle So class, for any rigid body yang mana dia tidak ada shape seperti yang tersenarai dalam jadual nota kuliah you, kalaulah dia bukan shape jenis ring ke, solid disk ke, dia bukan sphere ke, dan kita akan anggap semua rigid body tu sebagai partikel. Okay, so untuk objek yang tidak ada uniform shape, kita akan treat dia sebagai partikel, di mana moment inertia dia adalah mr squared. Okay, jadi untuk situasi ni, for the arrow, untuk arrow ni, kita akan treat dia sebagai as particle. Okay, we will treat it as particle, whereby the moment of inertia will be mr squared. Okay, understood Then we continue So we start to do our calculation. First, we need to solve question 1. We want to find the angular momentum of the arrow. So we treat this arrow as particles. then this arrow is moving with a speed 16 meter per second, 16 meter per second. So we want to find the angular momentum. So if you refer to the first video teacher gave, the angular momentum for particle, since we treat the arrow as particle, the angular momentum will be mRV. Okay, so the m is the mass of the arrow. Mass of the arrow is 100 grams. So 100 grams change to kg, it will be 0.1 kg. So how far? R, how far? How far is the particle from the axis of rotation? So how far is the arrow particle from the axis of rotation? So since that the length of the rod is 100 cm, then we pivot at the center. We pivot at the center. It means that the distance of the arrow from the axis of rotation will be 0.5 meter lah, half of the rod length. So 0.5. Then the speed of the arrow is 16. So when we do our calculation, we will get how much is the angular momentum. The angular momentum will be 0.8 kg meter squared second negative 1. Okay. So settle question 1. Then we move on to question 2. Question 2, we want to calculate the total moment inertia of the rod and the arrow. So the total moment inertia, the total momentum of the system. So for this question, we have rod and then we have the arrow. So the total moment inertia will be the moment inertia for the arrow plus with the moment inertia for the rod. Okay, so we treat the arrow as particle. So the formula to calculate the moment of inertia will be mr squared. Then what about the rod? The rod have uniform shape, and the formula for the moment of inertia for the rod is already given in the question. So we put it down here, 1/12 ml squared. Okay, then we substitute the value. The mass of the arrow is 0.1, and then the distance from the axis of rotation is 0.5 squared plus 1/12. The mass of the rod is 0.05 and the length of the rod is 1. Okay, then we do our calculation. We will get the total moment inertia of the system will be 2.92 to the power of negative 2 kg meter squared. Okay, so we settle question 2. Now we go for question 3. Question 3, we want to calculate the initial angular velocity of the rod and the arrow. So we notice that after the arrow hit and stick on the rod will rotate in a horizontal circle. So the question asks you to find, the angular velocity. What is the angular velocity? How fast the system will rotate in a horizontal circle. So if you notice, from question 1, we calculate the momentum of the arrow. So very starting, initially, this arrow have an angular momentum of 0.8. 0.8. So final this system is rotate. So they also have a final angular momentum. So according to the conservation of angular momentum, the total momentum initial must equal to the total angular momentum final. So initial is what? Initial is before the arrow hit the rod. Okay, final is after the arrow hit and stick on rod, and then they rotate in horizontal circle. Okay, macam gambar yang teacher lukis dekat atas ni ya. This is initial, this is final. So kalau you perhatikan dari question 1, from the question I, question 1, kita dah kira angular momentum of the arrow semasa dia bergerak. So kita boleh letakkan kat sini. So the initial angular momentum is how much? 0.8. Kita dah kira dekat soalan pertama. Final will be I multiply omega. This omega is the value that we want to determine lah. So 0.8. Final ada arrow dan juga rod. So the moment inertia will be 2.92 to the power of negative 2. So omega. So kita buat kiraan. Kalau kita buat kiraan, kita akan dapat omega will be 27.43 radian second minus 1.